Here's work on practice problems 21 through 25 of the MCA practice problems packet. Number 21 says use a chart below to answer question 21. Hours of sleep and grade point average. So they've got some students listed and then their hours of sleep per night and the GPA. Which of the following statements is supported by the data? Read all your possible answers to see what they're looking for. A. More sleep causes a person to have a higher GPA. B. A higher GPA allows a person to get more sleep. C. In the sample study, sleep and GPA are positively correlated. And D. School-wide sleep and GPA are positively correlated. Well, I see that they're looking for correlation, so the first thing I would do is quickly draw a graph, a little scatter plot, just to kind of give us some guidance. You don't have to graph every point, but just enough to kind of get us started here. So let's go through and guide. First one is hours of sleep. So sleep at the bottom here, and we're going from low of 4.3 to a high of 7.2. So let's go increments of 4. 4, 5, 6, 7, 8. Sorry, increments of 1, but starting at 4. So we'll do a little squiggly to say we're starting at 4, and then we'll go from there. And then GPA is going to be our y-axis. Sleep is called the explanatory. GPA is what we call the response. It's responding to how much sleep we have, or it's the y-axis, and this is the x. When they give you data like this, it's more than likely always going to be x then y. All right, and then our GPA goes from a low of 2.1 to a high of 3.6. So let's go squiggly and start at 2, and then maybe 2.5, 3, 3.5, and 4. And then let's graph a few points. You don't have to graph all of them, just to kind of get us started. 7.2, 3.5. Realize that this is just a coordinate. 7.2 over 3.5 up puts us right about here. 4.3, 2.1 is my next one. So 4.3, 2.1 will give me a point right around there. 5.5, 2.6 is the next one. Puts me right about there. Then 5.1, 2.5, 5.1, 2.5, puts me right about there. And then 6.2, 3, so go over to 6.2, 3, puts me right about there. All right, I think that's enough points because I get what's happening here. I can look at this and say it looks like we've got a line of best fit, some kind of correlation line, and it's a pretty strong positive correlation. In other words, it's going uphill. It has a positive slope as you read from left to right. Let's now go back and read the question. More sleep causes a person to have a higher GPA. Number one, more sleep, nothing is absolute. Notice we're bouncing around here a little bit. Nothing is an absolute, so to say it's a cause is incorrect. So I would cross out A right away. B, a higher GPA allows a person to get more sleep. A higher GPA means more sleep. Does that necessarily be the case? A higher GPA allows a person. Is that necessarily going to be the case? Not necessarily. I think we all know that a higher GPA is not going to allow somebody to get more sleep. It's just the way the graph turned out in this case. But again, it's almost like it causes. So I would say B is not the case. C, it says in the sample study. Ooh, I like that because this is just a sample. It's not the actual whole population. In the sample study, sleep and GPA are positively correlated. Pretty generic, but very true. Are they positively correlated? Yes, they are. The slope after you graph the points is going uphill, so I would say C is probably our best answer. But let's read D just to make sure. School-wide, sleep and GPA are positively correlated. We can't say that. We don't know about school-wide. All we can tell about is our sample study. So again, C is our best answer. D does not work. That would be number 21. Let's move on to question number 22. Use the graph below to answer the question. It says turkeys raised in 2001, and then they've got the number of turkeys in millions along the y-axis and the Minnesota versus North Carolina on the x-axis. Drew drew this graph to give the impression that Minnesota raised a much greater number of turkeys than North Carolina. To the nearest percentage, what is the percentage difference? Ooh, I see that word. What is the percentage difference between the number of turkeys raised in Minnesota and North Carolina based on North Carolina's number of turkeys? So we're basing it on North Carolina's number of turkeys. And they want a percentage. That is key, not how many. Notice these are all percents, not 1 million. I look at this and say, well, Minnesota had 44 million. North Carolina had 43 million, right? Look straight across. So that means there's a difference of 1 million between them. But we have to convert that to a percentage, and it's based on North Carolina's number of turkeys. So we're going to take that difference of 1 million and divide it by North Carolina's total of 43 million. And you can just divide 1 divided by 43 on your calculator, and you get 0.023. Therefore, our best answer to the nearest percentage is going to be B as in boy, 2%. Let's look at question number 23. Use the information below to answer question 23, and then they give you some ballots. It's 10 of the 11 ballots collected for student council representative from Mrs. Rodriguez's homeroom are shown. Using a runoff method of voting, which of the following ballots would need to be cast as the 11th ballot in order for Jan to win? We're looking for Jan to win. A runoff ballot means what you do is you go through and look at see who's got the highest votes, and at that point somebody at the end should have the majority vote, the overall majority vote. So let's go through and just mark. Looks like we've got 3 people here. We've got Jan, Anna, and Ed. And let's just go through and see who wins first in every ballot. In this one, it's Anna, so Anna gets a ballot. In this one, it's Jan. Jan gets a ballot. In this one, it's Jan again, so Jan gets another ballot. Jan for a 3rd time, so 3rd ballot. Anna gets 1. Anna gets another. Anna gets another one. Ed gets 1. Jan gets another one. And Ed gets another one. In this case, we've got Jan and Anna being the top leaders at this point. Ed is out of the picture. Problem is we don't have a clear majority. Jan and Anna, in fact, are tied at this point. So now what we need to do is we need to cross off Ed and go back and look and see what happens at this point when we go through and cross off Ed. Let's do this one in red. This time we're going to look at Jan, Anna, and Ed, no Ed. We're not going to worry about Ed. So let's go back through. In this case, Anna gets a vote. Jan gets a vote. Jan gets a vote. Jan gets a vote. Anna, Anna, Anna. Ed, we crossed out Ed. So now Jan gets the vote because that's the next person down. So Jan gets a vote. Jan gets a 5th vote. Ed gets another vote. Ed, we're crossing out. So now we're back to Anna. So Anna gets a 5th vote. Oh, we're tied again. So now we're at 5v5. That's why they're saying is on the 11th ballot in order for Jan to win. So let's go back and look at this. In order for Jan to win, we are looking for the top winner. And in this case, we've got Ed, who we crossed out. So Anna would be the winner. But we don't want Anna. So A is no go. In part B, Ed we cross out. Jan would be the winner. There's probably our answer. Let's just verify. In this case, Anna would be the winner, but we don't want Anna. And in this one, Anna would be the winner again, and we don't want Anna. We want Jan. So Jan being the winner would be B is our best answer for number 23. 24. There are 4 performers in a school talent show. In how many ways can the performers be arranged by different order of appearance. The way I like to attack these types of probability problems in order of how many different ways are there and different orders is I like to just think about it as 1, 2, 3, 4. Give yourself 4 lines because there are 4 performers. In the first spot, how many choices do I have right off the bat? We have 4 choices. Then we choose somebody. So now we're down to 3 choices for this spot. Then we choose somebody and we have 2 choices for that spot. And then we choose somebody and there's only 1 person left for that spot. This is like an AND statement. And 2 and 1. And in math means times. So 4 times 3 times 2 times 1, which gives us 24. So 24C is going to be our best answer. This is called the multiplication counting principle. You multiply the number of different arrangements, number of different possibilities together to get your final answer. Number 25. In the high school parking lot, 16% of the vehicles are trucks and 8% of the vehicles are painted yellow. If these characteristics are mutually exclusive, what is the probability that a vehicle in the high school parking lot will be a yellow truck? Out of this whole paragraph, it's really important that we understand these 2 words, mutually exclusive, otherwise known as disjoint events. What those 2 words mean, mutually exclusive or disjoint, however you'll see it on the test if you see it, means we have, if we draw a Venn diagram, we have 2 separate events with no overlap. There's no overlap here. In other words, we've got 16% of the vehicles are trucks. So here's trucks, and there's 16% that are trucks. 8% of the vehicles are painted yellow. So yellow is 8%. Now I know they're mutually exclusive or 2 separate events. In other words, there are no trucks that are yellow, as opposed to not being mutually exclusive where you get this kind of scenario. Here's trucks, here's yellow. You might get some yellow trucks, but that would mean we have overlap. And these events are disjoint or they're mutually exclusive. So the probability, the question was, what is the probability that a vehicle is a yellow truck? There is no yellow truck because they are 2 separate things. All the trucks are not yellow and all the yellow vehicles are not trucks. So we are left with 0%, no overlap. So A would be our best answer for question number 25. There's 21 through 25 of the MCA practice test. Hope the working through those problems helped.